We use electricity for everything, from turning motors to powering lights to running everything in our modern society that's based on a computer. But what if you want to store that power for just a little amount of time? Not a battery. Then what? In that case, you'd want to use the humble capacitor. There's a vast assortment of different types of capacitors, but the three most common types are the old school ceramic disc capacitor, the newer but still pretty old school polyfilm capacitor, and the veritable, tried and tested electrolytic capacitor, with electrolytic capacitors having the largest size differences. Now I'm getting a bit ahead of myself. I haven't even told you what a capacitor is used for yet. Well, when put in parallel in a circuit, capacitors are used to damper large voltage spikes. They do this by absorbing the high spike and releasing it at a slower rate than would otherwise occur. They're also used in simple timing circuits, as the timing device itself, with a resistor limiting the current flowing into the capacitor to adjust the speed the cap fills, thus changing the timing of the circuit. One of the reasons that capacitors aren't used as batteries is because they have such a high discharge rate rather than a nice, slow, moderated release. Another is that they can only store power for relatively short periods of time. The reason they are used at all is because they have a high cycle life and an extreme ease of manufacture. The long life means they can be charged and discharged millions of times, unlike most conventional batteries, only having a lifespan of a few hundred thousand charges under ideal conditions. Batteries also are extremely expensive to produce, requiring a multitude of expensive ingredients, including lithium, while capacitors don't. It's just 2 bits of aluminum foil and a bit of electrolyte. You may want to know what's inside of a capacitor. When I was 12, I wanted to as well, and I ended up getting chemical burns on my fingers. So, I'm gonna do the next best thing. And I'm gonna cut another one open, but with gloves. The first step is going to involve cutting open the protective lining on the outside of the case. Then proceeding to peel the entire lining off. There you get left with the raw canister. This raw canister, however, needs to be cracked. You know what we can crack it with? Nutcracker. Again, peeling back the entire case till you're left with the inner roll. This inner roll has a layer of tape that surrounds it. It needs to be cut. This layer can be split and begin to be peeled off, exposing our compound is separated by just a single sheet. Well, actually this one's 2 sheets. Get your foil layer here. And your other foil layer encased inside the paper, which is also soaked with an electrolyte. Going from this to this. The story of the capacitor begins with these: a bottle and a nail. Way back in 1745, a German scientist by the name of Ewald Georg von Kleist found that a jar filled with water and with a nail suspended in it could hold a small charge of high voltage current when he accidentally shocked himself one night late in his lab. This device later became as a Leyden jar, and that was the first capacitor. When the Industrial Revolution hit in the late 1800s, the need for capacitors became apparent when they became extremely useful in telecommunications, harboring their origins all the way back to the telegraph. Initially, capacitors were mostly the ceramic type, as it was cheap to produce and did a reasonable job of storing small amounts of electricity. The first electrolytic capacitors, however, were invented in 1896, when it was found that two thin strips of aluminum held very closely together with an electrolytic fluid suspended on a piece of paper in between them would hold a charge. Only in the 1950s did mass production of the electrolytic capacitor become viable, thanks to Bell Laboratories. Capacitors are now in nearly every single electronic device produced today. Now you know a little more than you did. A little science for your noggin on a late night YouTube scroll is always fun. But this is for class. And for you.